Hello students, I am here with another video from the chapter of class 10th NCERT book, that is periodic classification of elements. Before starting today's video, I would like to tell you all that till now what all things we have discussed in this chapter. So we started this chapter by seeing the utility of classification, where we found that if this classification is not there, we are not able to study the various chemicals, various elements which are discovered. Okay, so because there is a large number of elements which are discovered till now, that is, it is about 118 elements. Okay, so it is really very difficult for managing these 118 elements together, because we cannot classify, we don't have if we don't know the chemical or the physical properties of these elements, so we are not able to understand that where has to be, means how to study all these compounds in details, all these elements in details. So for doing this detailed study, we need to classify these elements so that it becomes an easier form to read all these things in a well mannered way. Fine. Now next thing what we will discuss is that we are going to check what are the next we saw that now how these different classifications are being given. So as the name suggests, it is the periodic classification, which means that from time to time the classification has been changed. Now first of all, if one scientist, one chemist has given one classification, if it was not justified by all in all forms, then what happens? That particular classification was discarded, as it was done with the Duvernier, it was done with the Newland's law of octaves, as it was done with the Mendeleev's even. Now after that, we have seen that there is another chance to classify all these elements in a better way. That was being done by Moseley in his periodic table, that is known as the long form of periodic table or modern periodic table. Okay. So which means that this modern periodic table is going to tell us about how are these elements being classified and what bases are there. So we studied about the features of modern periodic table, as well as we have studied about the the explanation regarding the trends in this periodic table. Okay, so the first thing was that to study the classification, to study where are these different types of elements being placed in that periodic table. Okay, so we found that there is a particular place of all these all these elements in the periodic table. Okay, so what is that place? We saw that there in this classification, the complete table of this classification is being divided into two parts, that is, it is divided into 18 groups as well as 8 periods. Okay, so we found that there are groups and the periods present in this periodic classification. Okay, and then we have also seen in the last class, we saw that there is a trend in this modern periodic table. Now what kind of trend we are talking about? We are talking about the sequence of the different periodic functions. Now what are these different periodic functions? The different periodic functions could be atomic mass, atomic number, the trends of the number is getting increased. How is this number getting increased, or what is that because of which, or what is the reason regarding all these trends in the periodic table? So this periodic table is based upon the periodic function of each and every element. So what is that periodic function? We have already talked about this periodic function we have already talked about. What is this periodic function? It means that it is related with the electronic classification or configuration. Okay. Now what is this electronic configuration? It means that the electrons, the atomic number is being classified. If it has 6 as atomic number, then it has to be classified as 2 and 4. Okay, so this means this is how we can talk about the configuration, and why this is so important, as this periodic classification is based upon only the factors of the atomic number. Now if we talk about this atomic number, which means that we are already talking about the different other properties also, as this atomic number alone is going to give us the number of electrons, number of protons and number of shells also. So this is what is about the complete classification. Okay, so this trend is based upon this periodic function, and this periodic function is completely dependent upon the electronic configuration, children. Okay, so please remember this electronic configuration, how to do this electronic configuration, that is the most important thing, and that we have already studied in the last, we have already studied in the class 9th, or you have studied in the previous class. Now, why this is being done, please understand that, and what is the reason why this is why this is happening, a particular trend is being followed, why the this atomic number is getting increased or decreased, or how is this size of the atom is going to increase or decrease. Okay. So, in the last class we have studied about the two functions of this trends, two of such these trends. The first was that the atomic size. So, we talked about the atomic size. So, what was that? The atomic size, how it is defined as? The atomic size is defined as the distance from the center of the nucleus to the outermost electrons, okay, to outermost shells we can talk about. So, if we are talking about the size of the atom which is being measured from the center of the nucleus, okay. So, it can be measured from the center of the nucleus till the last of this outermost shell, okay. So, this is how we can understand that what is the size of the element. So, what is the size of the atom of that particular element. So, if we talk about the size of the atom, so we need to measure it from the center of the nucleus, and it has to be measured till the outermost electrons, okay. So, this is what is about the atomic, the size of the atom, and this also follows a particular trend, children. Okay, now what is that trend? Let us discuss, let us find out that this trend is based upon the, this is why this is happening. This is based upon the number of shells present. Okay, the number of shells. The larger number of shells are present, it means that it is bigger is the atom. So, it means that it is very much necessary for deciding a period of an element where it is going to be present. So, it has to be decided because of the presence of the number of shells in the particular atom. So, what we saw that the atomic size is the distance between the center of the nucleus and the outermost shell of an isolated atom. So, what is this isolated atom? Isolated atom means we are talking about the atom which is stable or which is present in the form of the atoms of the elements. Okay, simply we could say that it is the atom of the elements. Fine. Now, it is also known as atomic radius. It is measured in picometers. This all we have already been seen. Now, what is the variation in the periodic table? Let's find out. So, the size of the atom decreases as we move from left to right. So, what is the trend? It is going to decrease as we move from left to right. So, what is the particular function? What is the need of this? This is going to be decreased. Okay, so what is being done? What is happening in the size of the size of this particular atom? What is happening? So, when we move from left to right, it means that where we are moving from left to right. The atomic size is, what will happen? The atomic size will increase. It is going to, what will happen? This decreases from left to right. This decreases is decreased, not increased. And when we move, down the group, okay, when we move down the group, what will happen in this case? When we are moving down the group, then what is happening? This, when we are moving from above to below, this is going to increase. The atomic size decreases, this increases, sorry. Now, why this is happening? This is happening just because of the fact that this happens just because that the fact that this, whenever we are moving from down from the above to down the group, when we are moving down the group, this atomic size is going to increase. So this is going to increase as when we are moving down the group, the number of shells are being added. Okay, now if number of shells are being increasing, it means the atomic size is increasing. Okay, so as it is given here in the example, in one example which we have discussed, that whenever we write down the atomic number, atomic radii of the elements, like it is 134 picometer, then 90, 82, 77, 75, 73, 72. Okay, so this goes on decreasing when we move down the group. Okay, when we are moving left to right in a period, then what happens? This is going to decrease. Now, why this is going to decrease? Because whenever we are moving from left to right in a period, then what is happening? This the nuclear charge is going to be added up. As the nuclear charge is increasing, then what happens? This is going to attract the electrons which are present in the outermost shell. As the electrons are being added up, as the electrons are being attracted by the nuclear charge, so the effective nuclear charge is increasing when we are moving from left to right. Now, what is this nuclear charge, or what is this nuclear attraction? This nuclear attraction means that whenever the electrons are present in the outer, as we know that the electrons are present in the outermost shell, and these the nucleus is going to attract, it is going to means it is going to have one type of force. It is going to have the type of the type of force which is going to be applied from the center of the nucleus to the outermost electrons which are present. Okay, so it is present, whenever it is present in the outermost electrons. So what is happening? It is going to attract these electrons as the effective nuclear charge is increasing. Now, what is this effective nuclear charge? This effective nuclear charge means that whenever the nucleus is there, this has some of the protons in it, and these protons are responsible for attracting the electrons which are present in the outermost shell. Okay. Now, what happens? This is because this reason is this is the reason because of which it is decreasing. Similarly, why it is increasing when we are moving down the group? Because one extra shell has been added, but whenever the extra shell is being added, this is not going to increase the effective nuclear charge, and this is not going, the new electrons are added in that particular shell. So what happens? There is no increase in the size, but there is increase in the number of electrons. So when the number of electrons are increasing, it is going to be increased. Why? Because the number of shells are also increasing. So please remember this. Okay, in the group, what happens? When we move from above to down, a new shell is added. Okay, so when the new shell is added, the problem is going to be over. So what happens whenever we are moving from above to down? So we need to discuss this. I think this we have not discussed earlier, so I am going to draw this for you all, and it will be easy for you all to understand that whenever we are moving, we'll draw all the group 1 elements. Okay, first we are going to draw this group 1 elements. After that, we'll write down the atomic radius. Okay, so once the atomic radius are being there, what is the, so we'll just look at this group 1 elements. Okay, so what is this group 1 elements which has the atomic radius of, when we will write down here, lithium, sodium, potassium, rubidium and cesium. Okay, so this is for 3, 11, 19, 37 and 55. Okay, so what is its atomic radius? Its atomic radius is 134, it is 154. Okay, this potassium's atomic size is 195. After that, this is 196, then rubidium is 211 and this one is 225. So as you could see that whenever we are moving down the group, this atomic radius is going to increase. So when it is going to increase, this will be smaller and this will be the larger one. Okay, why? Because the number of shells are also added up, because the atomic number is increasing. So for satisfying this atomic number, the number of shells will also increase, and when the number of shells will also increase, it is going to increase the size of the, this increases the size of the atom or nucleus. Okay, so this increases the atomic size. So that is what is present in the number of electrons are present, and we are going to see, we have seen that why the trend is being followed. This trend is being only followed just because of the one of the force, that is the nuclear charges. So this nuclear charge increases when we are moving from down the group or when we are moving from left to right. Okay. So now next we will discuss about the trends. Again we are going to continue the same topic, that is the trends in the modern periodic table. Now we are going to see the another trend. What is that? That is the metallic and non-metallic characteristics. So we will see this metallic and non-metallic character. Okay, so what is this metallic and non-metallic character? So we'll see this. Okay, so what is that non-metallic and metallic characters? So the tendency of an element to lose electrons to form cations is called, is said to be as electropositive or metallic character of an element. Okay, so what is this metallic character? Metal has a tendency. So all the metals have the tendency to lose electrons. Okay, so it has the tendency to lose electrons. When these electrons are going to, when these electrons are being loosed up from the atom, then what happens? When electrons are loose, then what happens? Then the nucleus will only be left with the protons. Okay, it is only be left with the positive charge. So whenever the positive charge is left after losing the electrons, the more positive charge is left. More positive charge is left, which makes this this atom electropositive. So this electropositive nature is said to be as the metallic character. Okay, so this is known as metallic feature. Fine, so this is what is about the metallic characteristic of the compound. So we have talked about the definition of this metallic character, or what is this electropositive nature. So electropositive, as the name only suggests the answer, it becomes electrically, it becomes positive. How this becomes positive? How this atom becomes positive? This atom becomes positive as the nucleus is present and the electrons are present in the outermost shell. So these electrons are getting lost. Once the electrons are getting lost, it means the negative charge is decreasing. If negative charge is decreasing, it means that what is left, we are only left with the positive charge which is present in the center, and this goes on increasing. Why? Automatically, because we have lost the electrons. I mean, the electrons are lost from this atom. So this atom on the whole now becomes electropositive, and this electropositivity only is known as the metallic feature. Okay, so this metallic feature is going to be is also going to follow the trend. Okay, so this becomes electropositive nature. Similarly, what happens in the non-metals? Okay, I'll just explain this non-metallic nature also. So non-metallic nature here, what does it means? It means that, so it means, what is the meaning of the next, that is the electronegative characteristics. What do you mean by electronegative? How it becomes electronegative? So we will see this non-metals now. Now what is the property of why it is called non-metal? It is very simple, that it is known as non-metals because it has a tendency to accept electrons. Now when one atom is going to accept more and more electrons, what will become? The negative charge is going to increase automatically. Why this is going to increase? Because the electrons are already present, and from the outer side also electrons only are being added up. So when the electrons are being added up, automatically this positive charge reduces. This positive charge is getting reduced. Why? This is very simple fact. If negative charges are increasing, it means electrons are increasing, then positive charge automatically it comes down. Okay, so this becomes electronegative characteristic. Why this is happening? This is happening just because the electronegative characteristic is increasing. So what is that electronegative? Electrons are getting added up, so it increases the negativity in the charges. Negative charges are being increased, not the negativity. I should say that negative charges are being increasing. So what happens? This is going to show you the electronegative character. So this increases the electronegative character or the non-metallic character, because this is the feature of non-metals. So this non-metallic character is going to be increased. And now what is the trend? We'll just discuss. So everybody has understood. I think now everybody might have understood what is the meaning of the word metallic and non-metallic character. Metallic character means losing of electrons, and non-metallic character means how to accept the electrons. How many more electrons could be accepted? Okay, so this is what is about when the electrons are being accepted. So it becomes electronegative. Okay, so the non-metallic character is going to be increased. Now when it is going to increase, when it is going to decrease, let us discuss. Okay, so this says that the tendency of an element to lose electrons to form cations. Now when the electrons are being lost, it forms cations. This is known as electropositive or metallic characters of the elements. Alkali metals are most electropositive. Okay, so they are these alkali metals are most electropositive. The tendency of element to accept electrons to form anions is known as electronegative or non-metallic characteristics of an element. Okay, just now I discussed that what is the meaning of the word electropositive and electronegative. Okay, so it is, make it very clear in your mind that whenever the electrons are added, extra negative charges are being added, it means the negative characteristic is increasing. It means to accept electrons is increasing, and for accepting electrons is the characteristic of non-metal. Okay, so non-metallic character is going to increase if extra electrons are being added up. Fine. Now what is the variation in the characteristic in a group? So what happens in group? Okay, to this metallic character and non-metallic character. Okay, so what happens to this non-metallic or metallic character? Let's find out. Metallic character increases. It increases. Where it is going to increase? When we move top to bottom of the group. Okay, when we are moving from top to bottom, it is going to, this metallic character is going to increase when we are moving from top to bottom. Okay, so what happens? This metallic character is getting increased up when we are moving from top to bottom in a group, because of the tendency of losing electron increases. So this metallic character is increased when we are moving down the group. Why this is increasing? Because we know that this metallic character only it is present when the electrons, when the atom can increase the means it could increase the characteristic of losing electrons. So losing or loss of electrons is happening. Electrons are being lost. Fine. So this electron losing capacity increases when we are moving down the group. Okay, children, please understand that whenever we are talking about the metallic character, it means that the electrons are getting lost. If electrons are getting lost, it means that the metallic character, the property of the metal is going to increase, and thus when we are moving down the group, the tendency of the electron losing capacity is going to increase. Why? As we are moving down the group, we know that the shells are increasing. If shells are increasing, then what happens? If number of shells are increasing, you know that positive charge is in the center. So this has to travel more distance. Okay, so this has to travel more distance. Then what happens? It is going to increase. It is going to be there. It is going to have more and more electrons. So what happens? Electrons can be easily be lost from the outermost shell, because the number of shell is going to increase. Okay, as we are moving as we are moving down the group, what is happening to the atomic size? As we have just now discussed, this atomic size, when we are moving in a group, the new shell is added, and what was happening, electrons are being added in that particular, and it is moving away from the nucleus. Once it is moving away from the nucleus, it is very easy for the electrons to go out, because the electrons are bounded because of this effective nuclear charge. Now, if this effective nuclear charge is decreasing, then what happens? It is going to increase. It is going to this electrons could easily be lost from the outermost shell. Okay, so why this is losing? As the effective nuclear charge is getting reduced. Okay, now next variation. Okay, so what is the variation in the non-metallic character in a period, or a metallic character? And just opposite it would be there, because if you are moving down the group, so what happens from one to another group, what is going to happen? The shells are increasing. So when we are moving down this left to right in a period, then it decreases. Very simple, because size was decreasing when we were moving from left to right in a period. So if size is decreasing, it means that there is a much more nuclear charges are present. It means that this electrons would not be easily been lost from the electrons, and if it is not easily being lost from the electron, these electrons are not being lost easily, then what would happen? The non-metallic, this metallic character is going to be decreased, and non-metallic character will increase. Now, what happens in a period? When we are moving left to right, then what happens? Then this energy is increasing. Then what happens? It decreases. The metallic character, is will increase. Okay, this is going to this is going to decrease. Why this is going to decrease? As I have told, when we are moving from left to right in a period, the atomic size is not going to increase, it is going to decrease. Okay, so when it is decreasing, it means that the effective nuclear charge which was present here was more, but here the effective nuclear charge was it was less, because it was more, because the electrons are getting attracted towards the nucleus positive charge, as the size was very much small when we were moving from left to right in a period. Okay, so one character is being this is related with the other character. Now, if you know the electronic configuration very well, then every problem will be solved in this periodic classification. Okay, so that is the most important part, and you should understand, and everybody should understand, everybody should know this atomic configuration, how to do it. So when we have just now, we saw that atomic size was decreasing when we move from left to right in a period. Now, when we are moving from left to right, what is happening? The charge was more here, and the charge was less. The nuclear charge was less here, but the nuclear charge was as compared to the last element would be more. So if the distance from the nucleus and the electrons is getting, if it is more, it means that easily the electrons will be lost, and if this is less, if electrons are very close to this positive charge, then what happens? It becomes very difficult for this electron to move out. When it is very difficult for the electron to move out, it means that the nuclear charge is getting increased, and if nuclear charge is increased, it means that when we are moving left to right in a period, then what happens? The metallic character is going to decrease. Why? Because tendency of losing electrons is getting decreased. Now, if tendency of losing electrons is getting decreased, it means that what about the other one? What about the other? So means non-metallic character. What would happen to non-metallic character? So this non-metallic character will increase. Just vice versa. As this non-metallic character means acceptance of electrons. So if the nuclear charge is more when we are moving from left to right in a period, then what happens? This metallic character decreases, whereas non-metallic character increases. Okay, so this is just opposite to each other. So I have told you the reason also why this is happening. This is very simple concept, that when the distance from this nucleus and the electron is very much, it is far away, then what happens? This electrons could be easily being lost. Now, if the nucleus is very close to this electron, it is going to attract the electrons from the outermost shell, and it could remain bind with this nucleus for a longer time, and it becomes very difficult for this electron to move out. So if it is not able to move out, then what happens? This is going to means this electrons, all these species, or this atom is not going to lose electrons easily, as the positive charge is going to bind this electrons very in a very strong way. Okay, so when we discussed about the first characteristic, that was when we are moving in a group from up to down, then what happens? The metallic character was increasing. Why this was increasing? Because tendency of losing electrons was more, because the last element which was present down the group, that whose size was larger one, and if size was larger one, it means that it was the atomic radius also increased. If atomic radius increases, then the effective nuclear charge would be acting in a very lesser manner, then because of which what happened, the electrons it is difficult for the electrons to get lost. Okay, from this from getting loosed from this atom. Okay, so this becomes very difficult. So because of which the electropositive character is going to increase when we are moving down the group, and it is going to decrease when we are moving left to right. Okay children, so that was all about today's video, and we have discussed one more trend about this periodic classification. Okay, so this was all about today's video children, in which we discussed about the trend in the modern periodic table, and about the metallic and the non-metallic character, as well as the size of the elements. So we are going to discuss more about these trends in the next class. Okay, so that's all for today. I'll meet you all in the next video.